Okay, so today we're going over solving equations that have variables on both sides. The very first thing you want to do is you want to combine like terms, but in order to combine like terms, they have to be on the same side. Then we're going to choose sides. We want the variables to be on one side, and we want the constants to be on the other side. So let's go through a couple problems and see what happens. Remember, you can pause the tape, rewind it to help you understand a little bit better. So let's blow this up so you can see it better. And so on the first problem, we're looking for, so we have our left-hand side and we have our right-hand side. And so notice on the left-hand side, we have two terms. We have a variable term and a constant term. And those are not like terms, so we cannot combine those. On the right-hand side, we have a variable term and a constant term, and those are not like terms, so we cannot combine those. These are like terms, but they're not on the same side. So remember, you can only combine like terms if they're on the same side of the equal sign. So step one is to combine like terms, and we do not have any like terms in this problem to combine. So our second step is to choose sides. So basically, we want to say, okay, I'm going to have my variables be on this side, and I want my constants to be on this side. It doesn't matter which side you choose for your variables or which side you choose for your constants. So just make a decision and go with the decision. So basically, on this side of the equal sign, we want only variables. And on the right-hand side, we want only constants. So basically, we're going to look at each side, the left and the right, and we're going to start kicking terms out that don't belong, and we're going to do them one step at a time. So I just usually look at the left-hand side first, so I'm going to look at the left-hand side, and I'm going to see who needs to be booted out. So remember, we decided that we're going to have only variables on this side. So that means we have to boot out the 12. So if we're adding 12, then we have to subtract 12. And whatever we do to one side, we have to do to the other. So that line up your equals. And so positive 12 and negative 12 is 0. So that leaves me 8x on this side. And I still have my x on this side. And then a negative 3 and a negative 12 is a negative 15. So you can stop the tape, kind of think about what that means. So notice on this side, I now have just variables on this side. So now I'm going to go to the right-hand side, and I'm going to look, and then I'm going to see who do we need to kick out, if anybody needs to be kicked out. And on this side, we said we only want constants on this side. So that means no variables are allowed. So think of them as like maybe being houses and like, hey, you know what? You got to go now. You're not allowed to be in my house anymore right now. Like mom says we're having dinner and we can't play anymore. So you got to go. So basically we have to undo the positive 1x by subtracting 1x. So when you're kicking somebody out, you're just adding the opposite of it. So adding or subtracting to undo to kick them out. And then what do we have on each side now? So 8x minus 1x is 7x on this side. And then a positive 1x and a negative 1x are 0x's, and that leaves you negative 15. So to undo or to kick somebody out, you're either adding or subtracting that term to kick them out. And so notice we've actually met our goal. Our goal was to get the variables on one side and the constants on the other. And we have met that goal. We have just variables and we have just constants. So that's our first goal, and we've met that goal. So now we can finish the problem by undoing, right? So this was 7x, so we can undo multiplication by dividing both sides by 7. And that gives us x equals, and a negative divided by positive, when the signs are different, it's a negative, and 7 times 2 is 14, so this turns out to not be a division fact. It's just a regular fractional answer, and if we wanted to, we could write it as a mixed number. So negative, let's see, 7 times 2 is 14 with 1 left over. So you can write it as a mixed fraction, or you can write it as an improper fraction, either way. So let's look at number 2. So remember, when you're doing videos, you can pause them and stop and say, you know what, I'm gonna try this one and get as far as I can, or I'm gonna try the first step and see where that leads me. So on problem number 2, we first want to look for combining like terms. So we want to focus our eyes on the two different sides. And notice on this side we have x's and x's, so that these are like terms, so we can combine those. And on this side we have a constant and a constant, so we have those, so those can be, and they're on the same side. So remember, they have to be like each other, and they have to be on the same side of the equal sign. So we actually do have like terms. So a negative 1x plus 3x's gives me 2x's on this side, And notice when we're combining like terms, we don't show any work. So when you're combining like terms, it's just like Nike, you just do it. And then a -8, I like to put my x's first, and then a -8 and a -4 is a -12. Either way, it doesn't matter. So after you can, so notice on the combining like terms, there's no work, you just kind of do it. Right? And now we're going to choose our sides. Which side do you want the variables? Which side do you want the constants? It doesn't matter which side, it's all going to come out the same. So I'm going to pick the variables, and sometimes kids go, you always pick the variables on the left-hand side. You don't have to. It kind of depends. So you don't have to. It'll all be the same. So remember, on the variable side, we only want variables. So nobody needs to be kicked out, right? So here we're good. Nobody needs to be kicked out. And on this side, we have to only have constants. So I always look at each side first. So I tend to look at the left side first, and I go, does anybody need to be kicked out? Nope, everybody's good there. And then I look at the right side and I say, does anybody need to be kicked out of the right side? And we said this was going to be the constant side. So the variable guy has to go. So the positive 6x, I'm going to kick him out by doing a negative 6x. And whatever you do to one side, you have to do the other. And then line up your equals. So on the left-hand side, 2x and a -6 gives me a -4x's, right? When you're adding terms, you're looking at the coefficient. And then 6x and -6x is no more x's, and now I have a -12. So notice I've met the goal. I've got my variables on one side, and I have my constants on the other. And so we've met that first major hurdle. And after we've got and isolated our constants and variables, then we can undo. So now we can undo multiplying by a -4 by dividing by a -4. 4 divided by 12 is 3, 12 divided by 4, and the signs are the same. And if the signs are the same, it's a positive. And normally we wouldn't write the positive symbol. I was just doing that just to emphasize your rules. Okay, and then you want to try to, eventually you want to try to do it without the boxes. So if you're really struggling, try using the color like I'm doing, and then see if you can get away from using the boxes and the colors if you need to. So that's a strategy of learning something. So now we got to show our check. So I'm going to show the check here. So I think we said the answer was 4. Hopefully I remember that's what it was. I don't know if it was 4 or 3. Do you guys remember? So we're going to go back to where all the x's are, and we're going to plug in where all the x's are. We're going to plug in whatever we got as the answer, and I can't remember. So I'm going to put a parentheses there. Hopefully it was 4. I have to end up doing this all over again. So we're going to put negative, and there's where x used to be, and then plus, and then 3, there's where x used to be, and then is it, and then -8 plus 6, whatever x was, minus 4, and I think we said it was a 4. I can't remember if we said our answer was 4. I think it was a 3, actually. Wasn't it a 3? So I think our answer was 3. So I'll put a 3 there, because I think the answer was 3. And then we're going to do each side. So now we're not solving anymore. Now we're doing PEMDAS. And we want to see, do we get the same answer on both sides? So now we're not solving anymore. We're actually doing PEMDAS the normal way. So 3 times 3 is 9, plus -4 is 5. And then -8 plus 18 minus 4 is 10. And 10 minus 4 is 6. So they don't match. So something's wrong. So I have to go back and figure out what I did wrong, and it was because I didn't have the equation down right. Okay, because so what was the actual answer? Oh, it was 3, and so something went wrong. So let's see, what did I do wrong? So, I copied this down wrong. So see, they don't match. So somewhere I did something wrong. And 3 is actually the answer. And what happened was right here, I copied a 4 instead of a 3. So that's called a recopying error, right? So then that gives me 6 on this side. Oh, it really does work. So again, if they don't match up, then you've done something wrong, and trying to find your error can sometimes be really challenging. And what happened is I had a 3 here, but I was thinking 4 in my head from earlier, and I recopied that as a 4 instead of a 3. So see, they really do match. So that's good. It's good to actually show you where it comes out and it doesn't work so you can see what that means and how you have to figure that out. Okay, so let's look at number 3. So on number 3, again, what's the first step? The first step is to see if there's any like terms. So on this side, we have a constant and a variable, so those are not like terms. Over here, we have a constant and another constant, so those are like terms, and they're on the same side, so we can combine them. And when we combine them, we don't show any work. We just do it. It's like Nike, just do it. So negative 12 plus 5x. So we don't say add 3, like we don't show any work. That's actually wrong because you can't add to the same side. So all we're doing is just saying I have a negative 3 and I have a negative 4. So don't I have a negative 7 on this side and plus a 5x? Right? So we don't show any work when you're combining like terms. Then we're going to pick our sides. Right? So this time I'm going to say this side's the variables and this side's the constants, just so you know it doesn't really matter. So the constant terms, only constants can go on this side of the equal sign, and only variables are allowed on this side of the equal sign. So I usually just look at the first side first, the left side first, and I just see who needs to be kicked out. So this is only the constants, so only constants are allowed to be in here, so we have to kick out the plus 5x by minusing 5x. And whatever you do to one side, you do to the other. Right? And then a negative 5x plus 5x is 0 x's, and that leaves me a negative 12. And then a positive 5x and a negative 5 is no x's, and that leaves me a negative 7. And then you go, what happened to the variable? And remember, that's a special case. So did you recognize that the variable dropped out? So remember, if the variable drops out, right, there's no more variable. There's no variable anymore. And you get a false statement, right? Negative 12 does not equal negative 7. That means no solution. That means there isn't any answer that's going to make that sentence true. So that's a no solution scenario. Remember, when you get a true statement, that means all real numbers if the variable drops out. Okay, let's try the next problem. So again, also what you can do is once you watch a video, if you're really struggling, is go back and do the same problems in the video and write them down and then say, okay, I'm going to try this problem and then I'm going to go watch it again. And that's another way to learn from a video. Okay, so let's do number 4. So in number 4, the first thing we're going to do is look for like terms. So we're good here. And over here we have 2 constants. And they're on the same side, so we can combine those. And again, when we combine like terms, Nike, just do it. So negative 17 plus 2 is negative 15 minus 4x. Doesn't really matter which one you write first. You could have put the negative 4x first. Then we're going to choose our sides. I'm going to choose the variable to be on this side. And why do you think that's a really smart choice? If I choose the variables on that side, do you see why that's a really smart choice? Because I don't have to kick anybody out, right? Nobody needs to be kicked out, so that's one less move. Like in chess, you have moves to win, moves to meet that goal. That saves me a step. So it makes sense to have my variables here because I don't have to kick anybody out. So I look here and I go, who do I need to kick out? And there's nobody that needs to be kicked out. We're all good. And then I look at this side and say, okay, who needs to be kicked out? Who gets to stay? Who has to go? And this is the side that we said was just going to be constants. So that means we need to get rid of the negative 4x by adding 4x. And don't forget your x's. That's super important that we're not getting lazy. We're getting rid of the x's. So make sure that you're saying you're getting rid of the x's. And then a negative 12x plus 4x is negative 8x's. And negative 4x and plus 4x is 0 x's, and that leaves me negative 15. Notice how I have a tendency to go from left to right, from left to right, from left to right as I'm doing problems. Now we've met our goal, and we have all the variables on one side and all the constants on the other. So now we can undo multiplying by negative 8 by dividing by negative 8. And that gives me x equals, And then a negative divided by negative is positive, and 8 times what is 15? Nothing, because 8 times 2 is 16. So that means this is just a fractional answer. So 15 over 8, and I don't really have to write the positive sign. I just did it to emphasize your rules. And you can leave your answer as an improper fraction, or you can change it to a mixed number. So 8 times 1 is 8 with 7 left over. And I don't care which way you write your answer. I like, most of the time, I just leave it as an improper fraction as long as it can't be reduced. Like, does 2 go into both 15 and 8? No. Does 3 go into both 15 and 8? No. Right? So it can't be reduced, so we're good. Okay, last problem. I need a button that I could just erase it all at once. I don't know. Maybe there is. I just don't know how. Okay, this one looks scary. It looks like a big one. So do you remember what the first step is? So are you thinking about what the first step is? So memorizing those steps. The first step is to see if there's any like terms on each side. So I notice this time we have some x's and x's. So those are considered like terms and they're on the same side. So we can combine them. And here I have a constant and a constant. And so those are like terms, so we can combine those. And remember, when we're combining like terms, we just do it. So a negative 1x, right? And a negative 8x is a negative 9x's. And then plus the 7. And then a positive 8 and a negative 6. I like to write the x's first, but it doesn't matter. And then a positive 8 and a negative 6 is a positive 2. Right? So notice when we combine like terms, there's no work. You just do it. Nike. I forget how to spell Nike. Nike, just do it, right? And then now we choose our side. So I'm going to put my variables on this side. I'm going to put my constants on this side. Can we do it without the boxes this time? So, right, who do we need to kick out on the left-hand side? So I'm looking at the left-hand side of the equation, and I'm looking to see who needs to go and who gets to stay. So I said only the variables get to stay on the left-hand side. So don't I have to kick out the plus 7 by subtracting 7? And I have to, whatever I do to one side, I have to make sure I do to the other side. And then what does that give us on each side? Positive 7, negative 7 is 0. So that just leaves you negative 9x. I still have my 2x. And then a positive 2 and a negative 7 would be a negative 5. I guess I shouldn't put the little, right? Whatever. Now I've got all my variables on this side, so now I'm going to look at this side and say who gets to stay and who has to go, right? This is the side that I said I wanted to just be the constants. So the constants gets to stay, so I have to get rid of the variables by undoing. Line up your equals, and that gives me a negative 11x. 2x and negative 2x is no x's, and that leaves you a negative 5. Now I've met my goal, where I have all the variables on one side and all the constants on the other, right? I've met that goal. And then I can undo multiplying by a negative 11 by dividing by a negative 11. And then a negative divided by a negative is a positive. So that's going to be 5 11ths is my final answer. And then just leave it. I don't want it as a decimal. Just leave it as a fraction and just make sure it can't be reduced. I think that's it. I don't think there's another one. That's it. So I hope you understand solving equations that have variables on both sides of the equation. Variables on both sides of the equal sign. So that's what today's lesson was. How do we deal with that?